Alright, so we're into our third day of solving trig equations. So today we're going to be doing a couple different styles. Okay, so let's look at the first one. We need to find the solutions. Again, the 4 steps that I gave you guys yesterday. Set it equal to 0. Factor if you can. Set the factors equal to 0. Use the unit circle to find your solutions. Okay, so I'm looking at this one, already equal to 0. I'm good there. Is this factorable? Well, I have a trinomial, so it's probably factorable. So I'm going to go back to your Algebra 2 class and use something that you guys did in there to help you with this. Of course, the hardest part about factoring this is, like you guys say all the time, it's got more letters. But there's actually an idea that you learn in Algebra 2 called factoring by substitution that would help a lot here. Okay, so what I'm going to do is I'm going to say u is cosine x. And then that means that u squared is cosine squared. Okay? Then I'm going to use that and substitute it into my original equation. So right here, this is u squared and this is u. So that means my new equation here is u squared minus 5u plus 6 equals 0. And what that does is it gets rid of that excuse, the whole it's got more letters thing, and makes it really easy to factor. Okay? And most of my students, once I get it to this point, they could definitely factor this. So we're going to do trinomial factoring. So u and u. The factors of 6 are 1 and 6 and 2 and 3. Since this is a plus sign, I need the 2 that add up to 5, which means they are 2 and 3, and they are both negative. Okay, because the middle term's negative. So there are my factors. Now that's part of it, but now I have to plug cosine back in. So right here, using this fact, this ends up being cosine x minus 2 times cosine x minus 3 equals 0. Okay? Now we set each factor equal to 0, so we get cosine x minus 2 equals 0, and cosine x minus 3 equals to 0. Which means we're looking where cosine x is equal to 2 and where cosine x is equal to 3. So where is cosine x equals to 2? Nowhere. There are no solutions to that. Remember, cosine has to be between -1 and +1. We're talking about the unit circle here. There is no place where cosine is 2. And the same thing for the other one. There are no solutions for 3 either. So this has no solutions. Okay? So there's 2 things that I wanted to show you here. One, we could end up having no solutions at all, or what we call the empty set. 2, I wanted to show you substitution, factoring by substitution. And this was the easiest way to do it. Okay? And it typically is easier, especially when you get into some of the other ones as well, as tangent and the cosecants, when you have to factor those. It gets rid of all of the letters that you guys don't like. Okay? All right, let's look at the next one. Sine squared of 2x equals 1. So, following our 4 steps, step 1 is to set it equal to 0, right? But I also notice I only have one x term. So I don't have to factor this, so I'm not going to worry about it. I'm just going to solve for sine. So I'm going to divide both sides by 2. So I get sine squared 2x equals, my board's not cooperating, 2x equals 1/2. To get rid of the square, we square root. So we end up getting sine of 2x equals plus or minus the square root of 2 over 2. Remember we talked about this yesterday, that the square root of 1/2, once you rationalize, ends up being root 2 over 2, and don't forget that plus or minus. Okay? So we found our solutions, but instead of x equals, we got 2x equals, and where is sine plus or minus root 2 over 2? That's our pi over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, I don't want 2x. I don't care what 2x is equal to. I want to know what x is equal to. Okay? Which means I got to divide both sides by 2, and I get x equals pi over 8, 3 pi over 8, 5 pi over 8, and 7 pi over 8. Now, we could end up having more solutions. Okay? And we actually do, because I want all the solutions between 0 and 2 pi. 7 pi over 8, that's basically not even 1 pi, which means we're going to have to find the other solutions. So what I'm going to do here is I'm going to find my coterminal angles by adding 2 pi to these. So 2 pi is the same thing as 8 pi over 4. So these are my original 4. Okay. Now what I'm going to do is I'm going to add in the coterminal to the 4 I have. So pi over 4 plus 8 pi over 4, that's 9 pi over 4. 3 pi over 4 plus 8 pi over 4, that's 11 pi over 4. Then 13 pi over 4, and 15 pi over 4. Okay? And again, I'm going to divide those by 2. And that gives me my second set of solutions, which ends up being 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8. And you can see I'm at 15 pi over 8, which is almost 2 pi. So those are going to be, I can stop right there. Not to mention, this is the key indicator of how many times you're going to have to do this. I should have 2 sets of solutions. Since I divided my angles in half, I should end up having to do this one more time. So I should end up having twice as many solutions. If that were a 3x, I'd have to do it 3 times. If that were 4x, I'd have to do it 4 times. Okay? But that's what I wanted to show you guys. When you have this, you're going to have to find more solutions. So if you had stopped at the first 4, you would have been missing or only gotten 50% of the answers. So you got to be careful. Okay? But this is how you do it with if you have a double angle in there. Your code for today is going to be F1N1 SH3D. F1N1 SH3D.